Hello, this is Mr. Underkoffler, and today we're going to be looking at a quick review on solving two-step equations, and then we're going to go segue from that into an introduction on what we do with equations when there's variables on both sides. All right, so let's start with the top of these guided notes. Quick review. Whenever you're solving equations, you need to ask yourself what's happening to the variable. The order of whatever is happening to the variable is going to be in the order of PEMDAS, which is your traditional order of operations. But then from there, you're going to ask yourself, well, what's the inverse operations of that? Of course, the inverse of addition is subtraction, inverse of multiplication is division, and so on. But since the word inverse means to do the opposite thing, that is why we are not going to do our inverse operations in the traditional order of PEMDAS, but we're also going to do it in the opposite order. And so that's what this SADMEP is all about. We're not going to be sad as we solve these equations. It's just the phrase SADMEP is just taking the traditional order of operations, which is PEMDAS, and going in the complete opposite order. Again, the reason that makes sense is because inverse operations, the word inverse, means to do the opposite. All right, so real quick look at three examples that are already typed up on your guided notes. Problem number one. What's happening to the variable? Well, you can see that the y is being multiplied by -8. That's what it means when the number is right next to the variable. And then it's being added by 62. So we need to do the inverse of those two things. What order do we do our inverse operations in? Well, you recall it's the order of SADMEP, which means SA, subtract or add first, then later divide or multiply. And so that's the complete opposite order from order of operations. So instead of dealing with this timesing by -8, we're going to start in the opposite order and start with the adding by 62. What is the inverse of adding by 62? Of course, it's subtracting by 62. We're going to do that to both sides. Now, on the right side, we had a -36. How do you subtract when there's negative numbers? Well, I know some of you might be using a calculator, but if you're not, go back and think, how do we learn subtraction with negatives earlier this school year? We learned subtraction is the exact same thing as adding by the opposite. And so that way, without a calculator, you can realize -36 minus 62 is the same thing as -36 plus -62. When you have a negative plus another negative, you're going to add in your head, and that result will stay negative. And that's how we get -98. On the left-hand side, I don't really have to make the subtraction of 62 become add in the opposite because you're just subtracting it away from positive 62. So that's real easy. 62 minus 62 is 0. And that's why that part can mathematically just disappear, all right? Because anything plus 0 is itself. And so that leaves us with just the -8y. From here, let's do the inverse of multiplying by -8, which is dividing by -8. Let's go back over our rules of positives and negatives. When you multiply or divide two negatives, a negative divided by a negative will give you a positive. And you can use your calculator if you need to. 98 divided by 8 is 12 1/4, or 12.25. And on the left-hand side, the -8 divided by -8 would be +1. And +1 times y would leave you with just the y. And that is how we mathematically can get the variable by itself in order to solve. When we solve an equation, we are trying to find what value of the variable would make that equation true. In fact, guys, we can take this answer and we can prove that it works. We can substitute the 12.25 back in for the y. And we can ask ourselves, what is -8 times 12.25? Then take that answer using our calculator, add it by 62, and we would indeed get the answer of -36, proving that this answer for y, 12.25, is the one and only answer that actually makes this original equation true. All right, let's take a look at number 12. Or sorry, not number 12, number 2. We have w over -16. That means divided by -16. Then it's subtracted by 76. So that's what's happening to the variable. Let's do the inverse operations in the order of SADMEP. The inverse of subtracting by 76 is adding by 76. We do that to both sides. This will give me +4 because -72 plus 76, you subtract in your head, that gives you +4. Now we just have the w over -16 remaining. From here, What is that? That's division, right? Fraction bars mean division. The inverse of division is multiplication. So we're going to multiply by negative 16 on both sides. 4 times negative 16 would give you the final answer of negative 64. All right, one more problem we'll look at together. And again, this one is once again already typed up for you in your guided notes. Now, I gave you a little important information box from this problem. Let's look at this together. When the variable term, which in this case would be the 11n, that's the term that has the variable. When that term is to the right of the subtraction symbol, you can see the subtraction symbol right here, and this variable term is to the right of it, then in order to answer what's happening to the variable, we have to make it adding the opposite right away before we are going to be able to answer what's happening to the variable. Now, if you're like, what? Let me explain to you. If I try to ask what's happening to the variable, here's the variable n. What's happening to that n? Well, it looks like it's being multiplied by 11, but then I'd have to read backwards, going right to left to try to say what this part is doing to the variable. I got news for you. You cannot read right to left with subtraction. There are only 2 operations where you are allowed to go backwards or forwards any order you want, and that is addition and multiplication. And so, since this problem has the variable to the right of the minus, and we try to always answer what's happening to the variable, we cannot read backwards with subtraction. And so, this is why the information box is telling you that in this situation, you need to make the subtraction become adding the opposite right away. You have to do that right away. Otherwise, you are not going to be able to answer what's happening to the variable. But now we can, because now we have multiplication and addition. We can read multiplication and addition going backwards because the commutative property says that the order of addition and multiplication does not matter. So what's happening to the variable? It's being multiplied by negative 11. Then it's being added by 80. What's the inverse of adding by 80? Subtracting by 80. Now on the right-hand side, we have a negative 107, don't we? So here we can make the subtraction become adding the opposite, and that would give us negative 187. On the left-hand side, 80 minus 80, that's 0, so it's gone. What are we left with? The negative 11n. So that negative does not disappear, ladies and gentlemen. From here, we're not done. What's the inverse of multiplying by negative 11? Dividing by negative 11. A negative divided by a negative gives you a positive, and that's why the final answer is positive 17. So, again, moral of the story, when the variable term is to the right of a minus, make it adding the opposite right away, and that way you will be able to correctly answer in your head what's happening to the variable, which will then lead to you understanding what correct inverse operations you should do on both sides. All right, now that I've gone over 1, 2, and 3 with you, I want you to hit pause on the video, and I want you to solve numbers 4, 5, and 6 on your own. Of course, asking yourself in your head what's happening to the variable, asking what's the inverse, and doing those inverse operations on both sides in the reverse order from order of operations. So that would be the order of SADMEP instead of PEMDAS. All right, so hit pause on the video, do these 3 problems on your own, hit play when you're ready for me to go over them. Okay, I hope you have done these 3 problems on your own. Let's see how you did. On problem number 4, the x was being multiplied by 9, subtracted by 20, so you should have added by 20 as your first inverse operation. That would give you negative 45. From here, you would do the inverse of multiplying by 9, which is dividing by 9, and that would give you negative 5, because negative 45 divided by 9 is negative 5. Problem number 5. This was the kind of problem that had the variable term to the right of the minus. So just like I showed you on problem number 3, remember this problem we were just looking at? You're going to have to make subtraction adding the opposite right away. Otherwise, you are not going to fully understand what is really happening to the r. The r is being multiplied by negative 7, then added by 24. So you wouldn't have known that at all if you don't make subtraction adding the opposite when the variable term is to the right of the minus. So from here, let's do the inverse of adding by 24, which is subtracting by 24. No need to make the subtraction add in the opposite here. You're just subtracting it from a bigger positive number, 101. 101 minus 24 is 77. The negative does not disappear on that 7r. If you made that mistake, get your pencil moving, fix your errors. Negative 7r means negative 7 times the r, so we will do the inverse, which is to divide by negative 7 on both sides. And that will give you negative 11 because positive divided by a negative gives you negative 11. All right, problem number 6. The k was being divided by 3, then subtracted by negative 21. The inverse of subtracting by negative 21 is adding by negative 21. Now, if you want to make the subtraction become adding the opposite, feel free to, and that proves to you why this will give you the k over 3 by itself, because a positive 21 plus a negative 21 would actually give you 0, proving that the k over 3 is the only thing that remains on the left-hand side of this equation. Right-hand side, when you work down, will give you negative 60. From here, the inverse of dividing by 3 is multiplying by 3, and negative 60 times 3 will give you negative 180. And there you go. That's a quick review on solving two-step equations, meaning equations that have two things happening to the variable, which therefore that's why we're doing two inverse operations, one at a time, to get the variable by itself, which is how we solve the equation to find what that variable equals. All right, let's move on and let's segue into the next type of equation that I'm going to introduce you to today. And that is equations that have the variable on both sides. Take for the example the equation 8y plus 17 equals 38 plus 2y. As you can clearly see, this is a very different type of equation from what we've had before. The variable y is on both sides, the left side of the equal sign and also the right side of the equal sign. So if I would try to ask the question, what's happening to the variable? That's kind of useless. I mean, how do I answer that? Do I answer it based on the y on the left? Or do I answer that question based on the y on the right? I'd be totally confused. So trying to answer what's happening to the variable when the variable's on both sides, that's totally confusing and totally useless. So we have to treat these equations a little bit differently, at least at the beginning. Follow along with me. Therefore, whenever the variable is on both sides of the equation, like the example up here, your first goal needs to be getting the variable to be on just one side of the equation first. So this is a very different beast than what we were just looking at on problems 1 through 6. We need to somehow get the variable to go from both sides to just one side. Well, turn the page on your guided notes. This is the million-dollar question. How do we get the variable to go from both sides to just one side? Here is the answer to that very important question. The answer is we're going to add the opposite of one of the variable terms, and we're going to do that to both sides. Now, that might not make a lot of sense to you. Let me break this down and specifically look at the example that we were just talking about. 8y plus 17 equals 38 plus 2y. Directions: get the variable to be on just one side of the equation. Follow what I gave you in this information box. The way we're going to do that is we're going to add the opposite. Now, what does opposite mean? Opposite in mathematics means positive or negative. So we're going to add the opposite, positive or negative, of one of the variable terms. Who were the variable terms? 8y and 2y. Those are the terms that had the variable. So they're the variable terms, not the 17 and 38. They don't have the variable on them. So we're going to add the opposite of 8y or the opposite of 2y to both sides. And doing that will make the variable get to be on just one side. I'll prove it to you. Let's go with option number 1, adding the opposite of the 8y. What's the opposite of 8y? Well, since 8y is positive, the opposite of it would be a negative. So we can add by negative 8y on both sides. Now notice how I lined this up. I lined up the negative 8y under the positive 8y, and I lined up the negative 8y underneath the 2y. Why didn't I line it up underneath the 17 or the 38? Because you have to line up your like terms whenever you add or subtract. And so like terms means having the same exact variable. 38 and 17 don't have variables, so it would make no sense to put the negative 8y underneath the 17 or the 38 when 17 and 38 don't have a y. See, that would make no sense. So you got to line up the variable terms properly whenever you do this. That's one of the keys to doing today's second half of the guided notes correctly. All right, so what happens when I take 8y plus negative 8y? Well, I explain it for you over here in this information box. A positive plus a negative you would subtract in your head, so 8y plus negative 8y would give you 0y. But what does 0y mean? A number next to a variable means times. So this would mean 0 times y. What do we know about 0 times anything? We know that it always equals 0. So even though we have no clue what number y actually is, we do know 0 times it would just give us 0. So, boom, 8y plus negative 8y would give you 0. And what do we know about 0 plus 17? That would give us 17, because 0 plus anything is itself. That's actually the additive identity property that we talked about earlier this year. The right-hand side, positive 2y plus negative 8y would give you negative 6y. Do you see that we have accomplished the goal of the directions? To get the variable to go to just one side. We have successfully done that. And how do we do it? We did it by following what I just told you at the top in the box. We added the opposite of one of the variable terms. In this case, we added the opposite of 8y, which was negative 8y. And that gave us 0y, which really means just 0, because 0 times y is 0. And that is what made the variable disappear from that left-hand side. The other option we had was adding the opposite of 2y. The opposite of positive 2y is negative 2y. And so again, do that to both sides. You have to line up your like terms, so put the terms with y's underneath the other term with y. Make sure you guys are putting the y on the negative 2's here. Every year when I see kids do this, I see some kids who, I don't know if they're just not paying attention to the details. They don't actually put the y's on their negative 2's, or on the previous problem, the y's on the negative 8's. So please be very careful to pay attention to detail today on these guided notes. It is very important. All right, let me finish this off. 2y plus negative 2y, just like we were looking on the other example, that would give you 0y. And what does that mean? 0 times y, which is really just 0. And so that's the reason why the variable on the right ends up going away, because 2y plus negative 2y is 0y, 0 times y is 0, 38 plus 0 is 38. Now the variable is gone from the right-hand side. Left-hand side, 8y plus negative 2y gives you 6y, and now we have accomplished the goal. And that goal was to get the variable to be on just one side of the equation. If we were going to finish solving for y, then we would answer the question of what's happening to the variable and do the inverse operations on both sides, just like we had reviewed at the beginning of these guided notes. Okay, let's look at another example together. Problem number 2. 5 minus 6w equals negative 19w plus 70. Since we have on this problem the unique situation that I was talking about way early on in these guided notes, if I can refresh your memory going back here on your guided notes, whenever we have a variable term to the right of a minus, we make it adding the opposite right away. So let's apply that to the problem that we were just about to look at. And we need to see, we have the variable term to the right of the minus here, so we need to make that become adding the opposite. Okay, so what's our goal? To get the variable to go from both sides to one side. How do we do that? We add the opposite of one of the variable terms. We could add the opposite of negative 6w, which would be positive 6w. We do that to both sides. Notice how I lined them up. The terms with variables are lined up with the terms with variables. This is always very important. So double check, do you have the w's on the 6's as you wrote this on both sides? Did you line them up perfectly? Don't line it up underneath the 5 or the 70. That would make no sense. They didn't have w's. Line them up properly. All right, so what do we get? Negative 6w plus 6w, that would be 0w, which is really just 0. 0 plus 5 would give you 5. On the right-hand side, negative 19w plus 6w is negative 13w. So now we have accomplished the goal. We got the variable to be on just one side. That wasn't the only way of doing it, was it? We could have added by the opposite of negative 19w, which would be positive 19w. Add that to both sides. That would have given us 0 on the right-hand side, and 0 plus 70 is just 70. Left-hand side, negative 6w plus 19w gives you 13w, and that would have given us the variable on just the left-hand side, which again is the goal of the directions here. Get the variable to go to just one side. Okay, so number 1 and 2 were already typed up for you on your guided notes. That I already know. But number 3 is not finished on your guided notes. So get your pencils ready. Let's do this one together. We have 18m equals 11m plus 39. I want you to notice the left-hand side only had 18m. It didn't have like a variable term plus something else like we were used to seeing on the other problems. It had only the variable term of 18m. So, thinking ahead to what would be the easiest way of solving this problem the whole way, let's get the variable on the side that only had a variable term, which would have been the left-hand side here. So that means I'm going to add the opposite of 11m, which is negative 11m. So write that down. Make sure you line it up properly. Do not line it up underneath the 39 because they would not be like terms. Make sure you have the m's on your negative 11's. All right, 18m plus negative 11m, that would give me 7m. Right-hand side, 11m plus negative 11m is 0m, which is really just 0, and 0 plus 39, additive identity property, gives you just 39. Now, the reason I suggested to get the variable on the side that was shorter is because, look, if I wanted to solve this, there's only now one thing happening to the m, being multiplied by 7. Now, I know the directions didn't say to solve these problems on this last page the whole way, I know. But if we were going to solve the whole way, this only has one inverse operation that we would need to do on both sides, dividing by 7, to finish solving the problem. So that's why if you ever have an equation where the variable's on both sides, but one of the sides is real short, it only has the variable term, it's the quickest way of doing the problem in the end if you get the variable on that shorter side. That leaves you with that leaves you with less stuff to have to deal with to finish solving the problem. Okay, problem number 4, 5, and 6. Try these problems on your own. In fact, you know what? Let me go ahead and do number 4 with you, and then maybe you can do the rest of them on your own. Number 4, we have the variable obviously on both sides. Now, one thing I want to remind you, x by itself is the same as 1x. And so with that in mind, you have a choice. You can either add by the opposite of 10x, which is negative 10x, or you can add the opposite of 1x, which is what I actually did here, and that is negative 1x. So that's one way of doing it. The other way of doing it is adding by negative 10x, like I had just said a few seconds ago. If you add by negative 1x, then you're going to get 9x on the left-hand side plus 82 equals 0, because that's what 1x plus negative 1x is, and 0 plus 31 is just 31. You'll notice I am not showing the 0 step anymore. If you still want to show it, you may. You don't necessarily have to, as long as you understand by now that when you add the opposite of the variable term, a positive plus a negative, subtract in your head, and that would always give you 0x, which is just 0, and 0 plus the 31 is just the 31. So I'm fine if you don't show the 0 step anymore. Right-hand side, or the other version, I mean, of doing this problem. If you add by negative 10x on both sides, then the variable disappears on the left-hand side because that would give you 0x, which is just 0, and that remains with just 82. Right-hand side would give you negative 9x plus 31. So that's the two different ways that you could have done number 4. That doesn't mean I actually want you to do it both possible ways. I'm totally fine with you picking whichever way you felt like doing. They both will work to get the variable on one side. All right, hit pause on the video. Do number 5 and 6 on your own. Then hit play when you're ready for me to go over them. Okay, I hope you did number 5 and 6 on your own. Let's see how you did. There's two ways of doing it. The best way, since number 5 had a side, the left side, with only a variable term, it's probably best to get the variable to end up being on that side. And so that means you want to get rid of the negative 15h. And the opposite of a negative is a positive. Negative 15h plus positive 15h would give you 0h, which is 0. And that leaves you with just the 63 on the right-hand side. Left-hand side, 22h plus 15h, 37h. That's probably the best way of doing it. I hope that's how most of you did number 5. You could have done it the other way. You could have added by negative 22h. That would give you 0h, which is just 0. You can't make the 0 disappear if it's the only thing that you end up having on a side of an equal sign. So do not make that become just a blank space. That's totally wrong. You need to have something on the left and right hand side of the equation. So if you did it this way, you have to keep the 0 on the left. You cannot make it disappear. So fix that if you made a mistake. Right-hand side would give you negative 37h plus 63, and that would accomplish the goal of getting the variable on one side. But guys, I hope you will see that the version over here on the left is going to be much simpler to finish if we were going to solve the whole way than the right-hand side version over here. So this is why I'm telling you, if you ever have a side of an equation that only has a variable term, get the variable on that side. That's going to be the easier way in the end. All right, problem number 6. You could either add by negative 9c on both sides or add by negative 33c on both sides, because the opposite of a positive is a negative. If you add by negative 9c, then it will end up giving you, now, I bet some of you might have messed up here. Do you see how this is a negative 45? You might be like, why is that negative 45? The minus does not actually disappear. Let me give you a better explanation. Do you remember how subtraction is the same as adding the opposite? Well then, this also shows you why the left-hand side is going to have negative 45 remaining, not just positive 45. So there's two ways you can think of this. You can think of it one way, the minus does not disappear when there's a number to the right of it. It actually makes it a negative. Or you can think of it in terms of what I've taught you before, that since subtraction is the same as adding the opposite, that proves to you that this is actually a negative 45 on the left-hand side. Right-hand side, 33c plus negative 9c is 26c. If you want to make this adding negative 10, I mean, you could. It's the same thing. You don't necessarily have to, but you could. It means the same thing. All right, the other way of doing it is adding by negative 33c on both sides. If you do that, please check. Did you realize this ends up being negative 10? Remember, subtraction is the same as adding the opposite, so that minus in front of the 10 does not disappear. It becomes negative 10. So that's why it's negative 10 on the right-hand side. Left-hand side is negative 26c minus 45. If you want to make that plus negative 45, you could. It was subtraction after all. It's the same as adding the opposite, so I'll leave that up to you. You don't have to make it add in the opposite necessarily in that situation. Okay, there are 3 more problems to go. 7, 8, and 9. Hit pause on the video. Do them on your own. Then hit play when you're ready for me to go over it with you. Okay, I hope you've done 7, 8, and 9 on your own. Let's see how you did. There's 2 ways of doing these problems. You only had to do it one way. One of the possible ways in number 7 was adding by negative 8n. If you did that, that would give you negative 71 equals negative 6n. Remember, subtraction is the same as adding the opposite, so that proves to you why that gives you a negative 71, not a positive 71. The other way of doing it, which I would not recommend, but you could have added by negative 2n on both sides. The reason I don't recommend that is because that would give you 0, and you can't make the 0 disappear. And notice, there's now 2 things happening to the n. I know we're not solving the whole way today on the second half of these guided notes, but if you were, that would take 2 inverse operations to finish solving. The other version that I did for you first here would only have 1 thing happening to the variable, and therefore only 1 inverse operation to solve. That's why the best version is the version I showed you over here, over on the left. That's the best way of doing a problem where one of the sides has only the variable term. All right, moving on. Number 8. Did you guys remember how a variable by itself is 1 times that variable? So with that in mind, you can add by 10k if you want to do it that way. The opposite of a negative 10k is a positive 10k. That gives you 0 plus 3, which is 3. Left-hand side gives you 11k. Remember, k is the same as 1k. 1k plus 10k, 11k plus 25 equals 3. That's one way of doing it. The other way of doing it, adding by negative 1k, that would give you just the 25 on the left because 0 plus 25 is 25. Right-hand side, a negative plus a negative, add in your head, stays negative, negative 11k plus 3. If you thought two negatives make a positive, that's only true when you multiply or divide. When you add two negatives, the result is still negative, so that's why it's negative 11k if you did it this way. All right, very last problem. Since the variable term of 4x was to the right of the minus, this is that situation I was telling you where whenever the variable term's to the right of the minus, make it add in the opposite right away. So that way you realize this is really a negative 4x that you're dealing with. And therefore, you could add by positive 15x, because that's the opposite of negative 15x, or you could add by 4x. It's your choice. Both ways will work. But remember, the opposite of a negative is a positive. All right, if you added by positive 15x on both sides, that would give you 16 plus 11x, because a negative 4x plus a positive 15x, subtracting your head, that gives you positive 11x, and that would equal 20. If you did it the other way, where you add by 4x on both sides, then you would get 16 by itself on the left. Right-hand side would give you negative 15 plus positive 4 is negative 11x, and then plus 20. And there you go. That is the conclusion of these guided notes, where we started by reviewing how to solve two-step equations, and we finished off with a very important introduction on how you get the variable to go from both sides to one side. We'll see you next time.